Welcome to Lecture 10 of Stanford CS193p, spring of 2025. So it's all demo today, all the time. We are going to learn all about what we talked about in the last lecture, including things about the protocols, and then we're going to move on to making our app much more powerful. It's going to have a lot more screens and views in it. And I'm going to start by doing a little bit of work here when it comes to this ForEach, which I kind of mentioned in the slides as an example here. We're using the indices of our attempts to show all of our attempt codes here, and we even reverse them because we want to be able to add our attempts at the end of the array, but we want to show them at the front. And we could change the whole way we think about this ForEach by just not using the indices. So if I take indices off right there, then this index right here becomes an attempt, because now I'm ForEaching over the collection of attempts. Yes, it's still reversed, but I'm now doing it over an attempt. And that means I have to change everywhere where I'm using the index, like here. See, I'm using the index to get the attempt. This is just the attempt, which is nicer code right there. Same thing here, attempt. And I'm also using the index here. This is where I am hiding temporarily the markers for the most recently made attempt, the one that was the last guess. So I can't use index here, but I could do a lot of other things. For example, I might say attempt, the attempt that we just tried, its pegs don't equal the game.attempts.lasts pegs. But there's a couple of problems with this whole change I just made. I told you that a ForEach's collection, we have to have an identifier that's what? It's got to be unique within there, which this is not. Now in your A2 it was, because I forced you to make your attempts unique. I said don't allow someone to make the same attempt twice, but I don't do that here, so that's no good. The second thing is it has to be stable, which this is stable, because once an attempt is made, you can't go back and change those pegs. So the fact that we're not changing the pegs means those things stay the same. Even if I reordered them, it would still be the same attempts if I'm looking at the pegs like I am here. And then the third thing is it has to be hashable. The thing that is the identifier for these things has to be hashable. And right now, the identifier we have is self. The code itself is the thing that we're using to be identifiable. And of course, it's complaining here. And what's it saying? It's saying that this reverse collection blah, 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 aka code is not hashable. It must conform to hashable. See where it's saying that? Must conform to hashable? Well, that's because that's one of the three things we had to do. So let's go make code be hashable so that it can be the unique identifier for the codes themselves, so that we can use self as our unique identifier. So I'm going to go over here to my model. Here's my code right there. It's not currently hashable, right? It's nothing. It's just struct code. And I'm just going to say :hashable. And now I cross my fingers and I hope that Swift can synthesize hashable conformance for me, because it can often do that, where it'll just do it for me. But unfortunately, it couldn't do it. You see, it says there, type code does not conform to hashable. And in fact, if you click on this and you read carefully the error message here, it's a fantastic error message, because it says code.kind does not conform to hashable, which is preventing synthesized conformance of code to hashable. It's even telling you why it couldn't do the magic synthesis of it, which is that kind is not hashable. And sure enough, while kind is equatable, it's not hashable. So let's try make kind hashable. Hashable, comma, cross our fingers, please. Yes, no error. So we could make kind synthesized hashable. And why is that? That's because kind is an enum. All its associated data is all hashable. Same reason we could do equatable on kind and didn't have to do anything, because they were all equatable. They're also all hashable, which means bool is hashable, of course, and match is hashable because it's an enum that has no associated data, so it's hashable. And then, of course, array of match is hashable because just like an array of equatable things is equatable, an array of hashable things is hashable. So we're good to go here. We've got code. It's hashable. We're rocking. And we can go back here to our CodeBreaker view. No errors. However, this seems like everything is working, but it's not, because there's the other thing, the uniqueness. Right? These things are not unique. I can make the same guess twice, and it's going to confuse the heck out of the ForEach as to which view goes to which of those copies as things are moving around. So we have to go back to our CodeBreaker and make sure that they're unique in the same way that you had to do in A2. And I'm going to do that when I attempt a guess here. I'm going to guard against it being a copy of something that I already have. And so here's some code that does that. I'm going to say I do not want the attempts to contain where the $0.pegs equals the guesses pegs. So I don't want it to have any attempt that has the same pegs as this a guess. Otherwise, I will return. Just not do this. I can ignore this attempt if those pegs are already in there. So whew, now I've made them unique. So I've got all three things going now. This code self thing, it's hashable, nice. It stays stable throughout the time because I can't change my pegs, and it's unique. So I'm good to go here. Let's try it. Make sure that when we add new guesses, that it puts them in the right order, which it does. And if we guess properly, which is like yellow, orange. Okay, oops, did I get that wrong? My previews, it was actually yellow, black, green, brown. Yellow, black, green, brown guess. Okay, looks good. Seems to be doing the right thing. Restart, restarted it, excellent. Now, we could even go a step further here, and now that we've done this, making the codes be hashable, and get rid of the reversed. We were kind of doing the reversed because we wanted the stability of the indices as proxies to work so that we would always be adding attempts at the end. If we were adding attempts in the middle or at the beginning, then we would change all of our indices and all the things would not match up anymore. But now we're not doing that. Now we have a stable, unique identifier. We don't have to do that, so we can undo the reversed. Of course, if we undo a reverse, some things are changing, like this last becomes first, because now that's the first thing in the attempts. And over in our model over here, is over is now the first. And also when we make an attempt, we don't put it on the end, we insert it at the beginning. So I'm not reversing it in the UI anymore. Instead, I'm kind of reversing it in my model. I'm making it so that the attempts, the first one, is always the most recent one. So it's just kind of a semantic change to my model. Let's make sure that didn't break anything. There we go, guess. And now we'll really check and make sure this, yep, it continues to be the top one. And let's make sure that guessing works, orange, yellow, brown, 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 and guess. And yes, it checked the most recent one to make sure it was the match, and all is well. Now, I went to all this trouble to do this, and actually, I don't really think it's the right thing. And why is this really not the right thing? The reason it's not quite the right thing is that this ID self, all along, could have just been pegs. Because pegs, as long as I unique them, which I did, is a unique, stable, hashable identifier of each attempt. So why would I go all that trouble making it hashable, making kind hashable? It's totally unnecessary to do all that. So that's why I'm saying I kind of was showing you that to show you how it's done, but it simply wasn't necessary. I can go back here, make code not be hashable anymore, make kind not be hashable anymore, and this is all going to work just great because the identifier I'm using, pegs, it's hashable, and it's stable, and it's a unique identifier for the attempts. But one thing you could say I should do is to use the identifiable thing so that I don't have to do ID\.pegs. If you remember from the slides, I can take off this ID\.pegs if I have the things in the collection, my attempts, implement identifiable. So let's go do that. Let's take this off. This is going to complain because they're not identifiable, right? It says this only works if code conforms to identifiable. So let's go make code conform identifiable. We go to code. We're going to say :identifiable. We're going to cross our fingers and hope that Swift can synthesize it. It can't do it. All right? And Swift can basically never do this for structs. Because we've talked about structs and classes. One of the differences is that classes have a really good sense of their identity. Structs have no sense of their identity. So we have to tell the world what the identity of a struct is. So if we click on this one of the things it offers here, this little band-aid, is add stubs for conformance. And a lot of times if you make something conform to something and Swift can't do it for you, the fix here will put the stub in so you can fill it in with how you want to do it. So let's do fix. Watch this. Fix. It gave us a var ID of type object identifier, which is just a placeholder right there, because that's what the identifiable protocol is. It's just the var ID. And that var ID has to return something that's hashable that identifies this thing. So what are we going to do here? Watch this. Array of pegs, computed property that returns my pegs. We already determined that pegs are a unique identifier of me. So good to go. Go back here. Look, no complaints. Does it work? Well, here we go. Yes, looks like it. Go here. Orange, green, brown, green. Orange, green, brown, green. Guess. Look at that. Working like an absolute charm. Now again, would I do this? Some would say, yeah, because look at that line of code. What a beautiful line of code that is. For each of my game's attempts, attempt in go do something really looks nice. I agree. However, I would not do this. Not just don't need to, I wouldn't do it. And here's why. Because the identity of an attempt code is clearly its pegs, because we unique the pegs. But the identity of a code in general, is that really just its pegs? What if I had an array that had master codes and attempts and guesses in there, and I wanted to search for all the ones that had orange pegs? The identity is now not just the pegs, it's the kind as well. So I wouldn't do this because the identity is not semantically clear enough to do this. It's just much clearer here to instead say ID \dot pegs. Because I'm clearly saying for this for each, the identity I want for each attempt is its pegs, which I'm guaranteeing to be unique and stable, and I know that's hashable. So I do not want this identifiable, so I would actually take this off because I don't think this line of code right here is necessarily the true identity of the struct in all circumstances. That's all I wanted to do with hashable and equatable and identifiable to start here. We'll get back to these because we are going to use these later on. But for here, no need, and in some cases, maybe not even the right thing, right? Now let's get to the main event. What are we building here? I'm going to enhance my app so I can have multiple CodeBreaker games. Specifically, I want to be able to have a Mastermind style one. I want to have this one that I got on the screen right here, which is my Earth Tones one. I want to have other ones with other themes. I want to have multiple of them. And I'm going to present them to the user in a list, and they can click on them to play the game. So we are actually going to change our root view of our entire app to, instead of being a CodeBreaker, it's going to be a CodeBreaker chooser, a list of games. And I'm going to start right off the bat by doing that. I'm going to go down here to my CodeBreaker app. You see, here's my CodeBreaker app. This is my main program. We haven't looked in here much, but right now, when we run our app, it shows a CodeBreaker view. Instead, I'm going to have it show something else, like a GameChooser. And this is how you control what your app shows when it first launches. But of course, we need to write this little GameChooser view here. So let's do that. Let's go File, New. We're going to make a new from template, because it's a view. And pick SwiftUI view down here. Next. And we want to make sure we put it in our UI place, because it is UI. So I'll put it in there. And I'm going to call it GameChooser, just for choosing a game. Try to give it as descriptive a name as possible. I'm going to hit Create. And here it is. I've got the CodeBreaker view pinned, but I'm actually going to unpin that. And here's the GameChooser. Of course, it just says Hello World, like any view does when you first start. And what does this thing actually want to have, though? It wants to have a list of games. So this view right here, this instructional manual view called List, super powerful view. You see it all the time in iOS. everywhere in iOS. Like in the settings app, right? You're going through those settings. Those are all lists of various views, etc. In a social media app where you're looking at the latest things posted by someone, that's a list. These are all capital L lists right here. A list is kind of a combination of a VStack and a ScrollView and dividers and ForEach, all that stuff combined into one powerful thing. So it is a fundamental piece of making complicated apps. Anytime we have a list of things for people to choose from, 90% of the time we're using a list to do that. Now, what's in our list? It's a list of games. CodeBreaker games. So I'm going to create a little data owned by me, which is an @ state private var, the games. And it's going to be an array of CodeBreakers. And I'm going to start it equal to empty. So there's no games to start. Now again, I am making my model essentially be @ state in a view. This is the root view of my entire app, so maybe that's not so bad, but you could argue even this does not belong here, and that really maybe where this belongs is up in my app. You know that place where the @main is? We can put @ state there too. Maybe that's where it should go. But I'm not going to worry too much about it, because next week and the week after, we're actually going to have our games be persisted in a SQL database, and that's where they're going to live. Now, how am I going to show this list of games? Well, I told you list is like a combination of ForEach and ScrollView and all these things. So list has multiple initializers, but one of them looks a lot like ForEach, where you can say the games, the collection, you need the ID with the thing that uniquely identifies a game. And my list of games is actually showing like themed games, Mastermind theme, Earth Tone themes. So the thing that, look, AI got it right for me, the thing that makes mine unique is going to be the peg choices. Whatever peg choices have, Mastermind peg choices or Earth Tone ones or whatever, that's my unique one. And then in here, we're going to say game in, and then in the list, I get to provide any view I want for every game, okay, for each game. So what view am I going to use here? I basically want a view that shows me the peg choices, which we actually have a view for that already. It's called peg chooser. Choices are the game's peg choices. Now, peg chooser lets you choose them too, and I don't want the choosing. But if you remember when we did peg chooser, let's go back and look, peg chooser, we actually made the on choose functionality optional. You see that? See how that on choose is an optional function that gets called when we choose something? And so I'm just not going to provide it. And so since I'm not providing it, it's never going to get called. Nothing's going to happen. And I'm only doing this temporarily anyway, because eventually we want something maybe even better than just a peg chooser. But for now, the peg chooser clearly is going to show me my pegs. Everybody agree with that? And I can put anything I want in here. In a moment, we're going to put a VStack in here with some other things, but I'm just using this to get started here. So let's put some games into our list. We've got a list that shows all these games, shows the peg chooser for each one. So I'm going to go down here and I'm going to say on appear, when this list appears on screen, then append some games. So game.append, let's put a CodeBreaker with the peg choices. Let's start with our Mastermind one. That's red and blue and green and yellow. Look at that. It's even working as I type. You see? I'm seeing a list there with the first one. Now let's add some more, a couple more. I've got 3 of them that are the same. Let's make one of them be the earth tones, which is orange and brown and black and yellow, and I think I put green in there. And then I'm going to have a third one, which is bluish tones. So that blue and indigo and cyan. Maybe that's enough, just those 3. See what's happening here? See how it's making a list of the games that I created? And you maybe can't see it very well, but there's actually a little divider in there. Maybe I can zoom in and we can see it. Yeah, see this little gray divider? So it's kind of doing the auto divider thing. And we don't do anything, but it also supports selection. You see when I tap on it, it supports selecting the whole row. So list supports selection as well. And it's in a scroll view, so I can scroll up and down. See that? And this thing that we put in here per one can be arbitrarily complex. So let's make our CodeBreaker games, for example, nameable. So we can name this top one Mastermind, we'll name this one Earth Tones, we'll name this one Undersea or something like that. I'm going to go back to my model, CodeBreaker. I'm just going to add to my CodeBreaker another var called name, which is a string. And of course I got to add it to my init right here, the name, which is a string. And I'll have it default to CodeBreaker. That's going to be the default name of a CodeBreaker game. And I got to, of course, say self name equals name. So I just added the ability to name my code breakers. Simple. Let's go back to our GameChooser view here and have our things be named. So let's get this out of the way. We've got our code breaker. Here's the peg choices. I'm just going to add name. This is the Mastermind colors. And then we'll add a name for this one. Name. This is Earth Tones. And then this one, I said I would call Undersea, because Undersea is all blue tones. So we've got a name there. We would like this name to appear for each item in the list, right? No problem. We'll just go up here and we're going to say vstack that has a text with the game's name and the peg chooser. There. Whew. Looks nice. It could look a little better. I think my vstack might want to have leading alignment. Alignment.leading. That looks a little better. I also think my text is kind of the title of the game, so I probably want .font title. That looks a little better. You know, those Undersea ones are a little bit large. Maybe I want to restrict the height of those things, so maybe I'll go down here and say .frame. Now, I'm not going to use width and height. You see width and height there? AI, bad AI. Don't do that. And I'm telling you right now, please, do not use width and height. If you used it in your A3, we're not going to give you a check minus over that. But in A4, do not use width and height with frame. But I'm okay with you using max height or max width, because then it's still flexibly adapting to its environment, but it just doesn't get so big that it looks ridiculous, and actually maybe 50 is better. And yes, of course, I want to put that into a constant struct. I'm not going to do it now because time is of the essence here. You already know how to do that, but I would. But this is looking pretty good. How about we could put for each game the number of attempts we've made? That would be kind of cool, wouldn't it? Because these games, we're going to be able to be playing them and go switch over and play another game and then come back to this game and continue it. It's perfectly fine. You're especially going to want that for your game in A4. So how would we do that? Basically, it's just the text, maybe with our game.attempts.count. And then I guess I want to say attempts, like that or something, which 0 attempts, that looks okay for 0, but what if I said +1 to simulate 1 attempt? I get 1 attempts. 1 attempts, that doesn't look very good. And you might be thinking, oh, I know how to solve this problem. I would just have this word here, or even just the S, be a ternary expression. But actually, there's a much cooler way to do this. And I'm going to show you this, even though basically the response I wanted to get out of you with this is, there's a lot of stuff in Swift, and I can't teach you even a tiny fraction of it, and it takes a lot of exploration to get to it all. But there is actually a morphology mechanism built into Swift where it knows about plurals, and it knows about them in all languages. Because using S with a ternary expression, that only works in English. Not all languages put an S on the end of a plural, so you just can't do that, and we want our app to work in other languages. So I'm going to show you this. I'm not going to explain how it works, but I'm going to show it to you, and you're going to be like, whoa, you're kidding. You can really do that? Watch this. Up arrow, open square bracket around this whole thing. And then I am going to have this expression, this English language, but it can be in any language expression, be inflected here by saying true. So inflection is the thing that will pluralize something that's not plural. Okay, it knows about the parts of speech and things like that. And you can see that now it's saying 1 attempt, because I changed this to attempt, but look what happens if I go back to 0. 0 attempts. You see? So yeah, it's wacky. And there's a lot of stuff in there. I can't take a time out here and go show you the morphology stuff, but you can search for it and take a look at it and you'll be impressed. A lot of stuff in there. And I actually showed you in Ed Discussion, I posted the UI text checker too. I don't know if you guys got a chance to see that in a discussion, that you can actually use to verify that the guesses that your users are making in A4 are actually words. In other words, you don't have to restrict yourself to the very small list of common words. You might still use those for your master codes, but UI text checker, another big thing that has a lot of mechanism in there that I couldn't even start to explain at all in lecture. All right, so I hope you're getting an idea of how we do a list here. We just put the things we want a list of, and then we just start building the view for each one in there, and we can do really anything we want, any layout we want. Now, list itself is, of course, very customizable, and if you type .list as a view modifier, you will start to see a lot of list things. You see all these things, list item, tint, list row, inset. So I'm not going to go over all of them, but you want to look in the documentation for all the view modifiers to start with .list. Now, some of these view modifiers go on the list itself, like this one, list style. For example, the plain style list. See, the plain style list is a little different than the group style, which is the default. You see, group style, plain style. A little different. And some of the list things, though, they go on the things in the list. Like if you wanted to hide the row separator, that little divider, that would go on the rows you want that hidden for. So see, I'm putting this on the VStack inside. I'm saying list row separator dot hidden. See, it's hidden the row separator, and it's done it for every row. I put it on the row. So some things go there. And there's also things like .list background, where you can provide a view to go in the background, which could be, let's say, the color green. That's a green rectangle. But we'll zoom out here. This row background, I guess it's called. There we go. Now to put a green background on each one. And this is a rectangle, but this also could be a rounded rectangle. The corner radius of some size, 10 or whatever, and maybe its foreground style of yellow, and maybe we put some padding on there. So you can control a lot about the way the list presents itself with these .list view modifiers. So go check out in the documentation all the view modifiers that start with .list. I'm not going to put any of that stuff. I'm going to leave this plain style. The plain style is more for lists like this, where you're choosing amongst a bunch of things. The group style is more like for settings. The settings app, it tends to group the settings in little groups, and so group style is a little more appropriate for that. Now, right off the bat, I'm going to do something which you almost always do in a list, which is you take this guy and make its own helicopter view. So I'm going to take this out of here. I'm going to put a helicopter view in there. I'm going to call it a game summary, I guess. It's kind of a summary of a game. That's what's showing in the list. And let's go make this game summary helicopter view. New, here from template. It's a view. And make sure it's in UI, which it is. Called game summary. Create. Here it is. I'm going to get rid of this and paste what I had in there. And of course, it's providing a summary of the game, so we need to pass a game into it, the CodeBreaker that we want to show. And I was warning you last week, oh my gosh, you don't want to pass the whole model into things, but actually here you would, because this game summary is supposed to be giving a summary of the entire game. It needs the whole game. Now, I'm not passing it as a binding, though, because the game summary is only showing a summary. It's not editing it. So it's not too bad. And let's make the preview of this thing work too. So let's have a game here. Let's make some sort of preview-like game. We'll have its name be preview, I guess. And then we'll have its peg choices be, I don't know, just some random colors, red and cyan, yellow, some whatever we want to be, so that we have a nice preview. Now, this preview is showing it kind of nicely. But you know, it's not really showing it in the context of a list, and this game summary is intended to go in a list. So there's no reason in my preview I can't just put this in a list. And in fact, maybe I even want to have two versions of this in my preview. One of them is a .plain style list. So now I can see what the thing looks like in group style, and I can see what this game summary looks like in the other style. And I could obviously make my preview even more powerful, have multiple items in the list or whatever. So we got our nice little game summary there. Let's go back to our list. I want to show you one cool thing you can do with your list, which is you can divide up the list into sections that have different things, and this is what the settings app does. It divides into sections. Now, we don't need any sections here, but I'm going to do it just so you can see how you would do it. The thing about this, though, is if I wanted all of my games in one section and something else in another section, then I can't use this version of list, which looks like ForEach. Because the version of list that looks like ForEach, all of the things in the list are only the games. So instead, I'm going to just make this be a normal list, and I'm going to do the ForEach myself inside the list. But this is essentially what list is doing. It's got a ForEach inside of it. It's just built into it. Look, this didn't break anything. This is pretty much exactly the same thing. But the good news is I can put a section around this. So this is how you make a section. And the section has a header, which can just be a string or it can be a view. And so I'm going to put my games in a section called games. And then my other section, let's put a view like an image or something, system name. Let's say face.smiling. That's kind of a fun thing to keep us in a happy mood. And then I'm just going to put some things in here, hello, and maybe hello there, or hello world, or something like that. And you can see, look, I got two sections right there. And this is especially visible if I go back to the grouped view. And I might want to do things like have this little image that's the title be font.title. I can do that, of course. And I might even make a helicopter view to be my title. That's perfectly fine as well. And these games up here, you can see it picks a standard size font, which is a little bit small given how big our rows are. So I might also turn this into header text games.font, whatever. I'm not going to do it all, but you get the idea. Yeah, so great question. So why did I separate the games thing away from the list and put it here? And it was just so that I could wrap it inside this section. You see, there would be no way for me to put the section around it if I didn't break it out. But it's exactly the same thing. And in fact, I'm not going to do sections here because we don't really have any need for any sections. I just wanted to show you how it's done. So I'm going to go back and get rid of that and get rid of all this section business, now that you know how to do that. And I'm going to go back to plain style as well. So that was just a little detour to show you sections. And what's the next thing I wanted to show? All right. The real thing we want to be able to do here is tap on these things in the list and have it play the game, right? Go to our game playing view. We already have a view, knows how to play these games. So we want to tap on here and go to that view and play the game. And we call this navigating. We are navigating from one view to another view in our UI. So how do we do navigation? And the answer is we just wrap our little game summary line here in what's called a navigation link. And we're just going to take this navigation link, and inside the navigation link, we're going to put the view we want to navigate to, and its label is just going to be this game summary that we had. So inside here, we are going to put the view we want to show. Now that's obviously going to be a CodeBreaker view, but I'm just going to do a text for now. Let's say a text with the game's name or something like that. We're going to navigate to a text with the game's name. Now this is not working. Look over on my preview right there. It's all grayed out, and when I tap on it, absolutely nothing happens. So why is that navigation link not navigating to the text with the game's name? Well, that's because navigation only happens inside the context of a navigation view. And there are a couple of different kinds of them. I'm going to show them both to you. But the simplest one is called a navigation stack. So I'm going to put a navigation stack around my entire view here, this entire view. See the navigation stack? And I can put the list style on the navigation stack because it forwards it onto the inside, as we know most of these containers do. But I probably would put it right on the list. Just people reading my code might be looking closer to the list for the style, etc. And this navigation stack, it creates an environment in which navigation links can navigate. So let's try earth tones. Woo! Look at that. It navigated here, and look, it put a little back button up here so I can go back. Now, all of you have seen this everywhere in iOS, right? You click on something, you navigate, and you can go back. And this is how that's done with a navigation stack. Now, the real key here, though, is that we want to navigate to a CodeBreaker view that shows this particular game that we tapped on. So how do we do that? Super simple. Get rid of this text. Instead, in here, we're going to put a CodeBreaker view, but we're going to need to do what AI wants here, which is pass the game to it, because we have to tell it what game to show. And that's a bit of a problem for us, because we designed our CodeBreaker view to have the game be data owned by me. And here, we're trying to share this game with me. So we're going to have to go back to our CodeBreaker view over here and change this data owned by me to be data shared with me, essentially. So I'm going to take this out of here and put a new mark and make it data shared with me and put it back. And of course, data shared with me is not an @ state. What is a thing that's shared with me? An @ binding, exactly. So we're going to make this an @ binding. And an @ binding, we get to specify what type of thing gets bound, but we don't get to initialize it to something. So we got to take that out of there. And so here we have a binding. Someone can share with us the game, and we can show it. And of course, it has to be a binding because we are going to play the game, and that is most certainly going to edit it. And we want the person who's passing it to us to see those changes, because back here in our GameChooser, which we can't see because it's not compiling, but back here we want things like the number of attempts to update. So we're sharing this game between the two. Now, if this is passing the game as a binding, this needs to be what? How do I pass a binding here? $game, right? So I want to say $game. But that actually is not right, because what is game right here? Game is this argument to my closure. And what kind of things are arguments to functions? They're lets. They're not bindings or @ state or something, and you can only do $ on things that are @ state or @ bindings. So what the heck? How are we going to fix this problem? Well, list comes to the rescue. It has another initializer that you can put $ right there and $ right here, and now the things inside will be bindable. There'll be things that you can bind to. And this is just crazy syntax here, but it kind of makes sense. But what's going on here is you're essentially passing a binding to this @ state. You see, this is an @ state, the games. So here I'm passing a binding to list. And then list is doing this wacky thing here. This is very strange syntax here, because that's an argument to a function. So why does it have a $ there? But just suspend your disbelief, all right? That $ just means that the things inside here are bindable. They're kind of like @ states, but they're not. They're bindable things that bind into this collection, because this is a collection of things, so we're actually able to bind in there. There's only one other error. We see we still have a red error up here. It's back in our CodeBreaker view, because when we made this a binding, what did we break? Our preview. Yeah, our preview down here didn't used to take any arguments. So we need to pass a binding to something here, so I'm going to do @ state, I guess, private var, a game equals CodeBreaker. Again, I'll call this another preview one. And the peg choices, I'll say .blue and .red, .orange or something like that. And then when I have my CodeBreaker view, I can say game : $game. And that should work, right? Because game is an @ state, and so I can $ it to pass a thing to it, except for, look, this doesn't work. It says, @ state used in line like this, in line of a preview, will not work unless it's tagged with @ previewable. And I can't remember we've done this before, I don't think so, but basically we have to say @ previewable before the @ state. And then we're going to have another error, which is that @ previewable here can't be private. So I said always @ state private, except if you're doing @ previewable. In a preview, you can't do that because @ previewable, the way it constructs it, that can't be a private var. Our CodeBreaker view preview seems to be working. Let's go back to our GameChooser's preview. Here it is. Moment of truth. I'm going to click on Mastermind here, tap on it, and hopefully we're going to see a Mastermind game appear. Woo! We did. There it is. And hopefully we can play it. We get here, we guess, and hopefully when we go back, it'll say 1 attempt, and it does. Look at that, 1 attempt. How about another one? 2 attempts. So the two views, the list and the CodeBreaker view, are sharing our model via that @ binding, right? So this is a little bit of an aside, but you see in these lists, when you have lists of things, that you can swipe to delete. You've seen that, right, in iOS? Also, sometimes you can go into an edit mode and move them around, change the order. That's incredibly easy here. If you do this kind of list that has $ games, and only when you do that kind of list, there's actually another argument, which is edit actions. It's an array of things. One of the things you can say is .delete. And if you put that edit action in there, .delete, look, swipe to delete. And I hit delete, bam, gone. And I can also put another one in this array, .move, and that allows me to move them around. However, on iOS, where do I grab onto them to move them? I have to put it in a mode where I can grab onto them, and I do that with a special iOS view called an edit button. I have to somewhere on screen put an edit button. And the place we almost always put an edit button is in the toolbar at the top of the screen. You've seen it, I'm sure, in many apps. It has a little edit button at the top. You click it, now you can move the things around and also delete them. So how do we put something in a toolbar? It's super simple. We just go to the view to which the toolbar applies, and we say .toolbar, and then we put the buttons we want in there, like the edit button. This edit button is an actual view in SwiftUI, and look, there it is, called edit, and it allows us to go like this, edit. Now, one thing here, you can see it's in the mode, and see these little, we'll zoom in here, you see these little things, these triple things. That's the thing you grab onto with your finger to move it. Just a warning, this does not work very well in the canvas, the preview canvas. Like, let me try it here, let's see if it even works. No, see, it's not, it's kind of moving around, but it's flipping out from under my finger. It works a little better in the simulator. So let's go take a look at it in the simulator. Go into edit mode, and yeah, see, it's quite a bit better. Actually, it's working fine in here. I've noticed that sometimes it doesn't work in here so great either, but on a device it always works. So that allows us to reorder them, and also we can delete here as well, and we can still swipe to delete. This toolbar thing, notice I did not put it over here. And you might be sorely tempted to put it here because you're thinking, oh, this is the toolbar for my main GameChooser, I want it at the top. But this does not work. And in fact, if I unpause, you will see no edit button up there. Who puts the toolbar up there? It's the navigation stack. You can't have those little toolbars up there without the navigation stack. Just like it puts the back button in, it puts toolbars up there. And the way navigation stack decides what toolbar to put up there is it looks at what view it's currently showing. It looks at the view it's currently showing, because it might be showing CodeBreaker view, it might be showing that list. Whichever one is showing, it looks at the toolbar that's on that view and puts it at the top. So that's why this toolbar right here needs to be back on this list, because this list is what is currently visible in the navigation stack, and so its toolbar is in there. Now watch this. I'm going to navigate. Look, it's gone. The edit button is gone. That's because the toolbar the navigation stack is looking at now is the CodeBreaker view. What's its toolbar? It doesn't have a toolbar, so there's nothing up there with the back button in the toolbar. Yeah? I think you're asking, why can I put list style down here, but I can't put toolbar down there? That's because list style is just a view modifier that's modifying the container and everything in it, whereas toolbar is more specifying the buttons that should be in the toolbar when this view is showing in the navigation stack. So it kind of has a semantic difference there. Does that make sense? Let's go over here, though, to our CodeBreaker view and give it some toolbar buttons, just so we can see it in action. So I'm going to go over to CodeBreaker view. Here it is. And I'm going to add a toolbar to it, and I'm attaching it to, in this case, my V stack. That's a view that's going to be showing in the navigation stack when this CodeBreaker view is on screen. And what am I going to put in here? Well, how about if I put my restart button in here? I've got that restart button up here. It'd be kind of cool if I just put it in the toolbar. So let's do that. Grab my restart button, cut it out of here, put it in here. And it's completely gone. Ah, where is it? Well, again, that toolbar only shows when something that's capable of showing toolbars is showing, which is a navigation stack. So let's go down to our preview and put this in a navigation stack. Even though we're not going to be navigating in our preview here, we're still going to put it in there so that we get that title bar on the top that we can put our toolbar in. And look, it put the restart button up there. It noticed that it was a toolbar, so it didn't put the word restart. It just put the icon. And I told you that it was going to do that, right? Adapt that button to its environment. So that's really cool. You know, another thing we could put in there is our elapsed time timer. I actually kind of like it next to the master code, but if we wanted to, we could put it up there. So let's try that. So here is our elapsed time timer. We commented it out so it wouldn't be distracting us. I'm going to cut it out of here. And I don't even need this. Go down here and put it in right here. And this is kind of to show you that your toolbar items don't have to be buttons. They can be text like this. Now this looks pretty bad. It's too big, but that's big because I have this flexible system font. So let's just take that out of there. No flexible system font? That's actually looking pretty good. Now, one thing about the toolbar buttons is they can be on the leading edge or the trailing edge. You see both of these are on the trailing edge, but what if I didn't want them both there? What if I wanted the elapsed time, let's say, on the leading side, and I wanted the button on the trailing side? To do that, you have to actually wrap these things in something called a toolbar item. Because toolbar item lets you control the placement of the thing that's in there. So the button I want to be, let's say, top bar trailing. I wrap the button in that. And the other one I'll wrap in a placement, which is top bar leading. Now, if you have one of the things in your toolbar wrapped, they all have to be wrapped. In other words, a toolbar has to have all toolbar items or all non-toolbar items. You can't mix them. So this placement here, you can see that it's controlling where this thing is. Now you might think, yeah, this looks pretty good. I kind of like this. And maybe I even want it the other way around. Maybe I want this one top bar leading and this one top bar trailing. And you're playing around with this and you think you know what looks good. But you're going to actually find that sometimes the system knows better than you. For example, this looks fine right here, but it doesn't look very good here in our GameChooser. Watch what happens when I navigate to it. It's properly getting its buttons, but now that restart button is right next to the back button. So I'm tapping one or the other, and I'm getting the other one sometimes because I mistap. You don't want two buttons that do very different things so close to each other like that. So now you're probably like, okay, well, I'll swap them back. I'll put the elapsed time over there and this one over there. But you know what? Let's let SwiftUI make these decisions. And we do that back here in our CodeBreaker view by having our placements be more semantic placements instead of physical placement. For example, the restart button is our main action that we can do. It's our main toolbar button. So I'm going to change this to be primary action. That's the position, the placement of it, and Swift will decide where it goes. And then this one, the elapsed time, I'm going to just say it's automatic. Whatever you think is best, SwiftUI, that's the automatic position. And it's decided to put it right next to there, which actually is a very good decision because, again, back over here in our GameChooser, when we go over, I don't think we want the time over here by the back button either. I think this actually looks pretty good to have them both on the right. But SwiftUI is pretty smart, and it generally knows where things go. And this is only on iPhone, because there's iPad and other environments where maybe it'll make different decisions, because there's more space or less space or whatever. So let's let SwiftUI do its job and have these placements be semantic. Now, by the way, the placement automatic is the default, so we do not need to even specify placement automatic. Toolbar items that you don't specify will be automatic, yeah. Okay, so the question is, We used this navigation stack to wrap our preview and show this. Would we also maybe put a navigation stack around this whole VStack? Is that your question, essentially? And the answer is probably not. And the reason for that is this CodeBreaker view could work fine, not in a navigation stack. In fact, it was working fine as the root view of our entire app, and we wouldn't need it in a navigation stack there. Although now we probably would, because we put the restart button up in there, so we probably would want it to be there. But generally, we try to let the navigation stack stuff live at the highest level. It's the arrangement of how our app is navigating around, and we have the individual helicopter views tend to not put it. But we sometimes put it in the preview just because we want to see what it's going to look like in there, just like we sometimes put things in a list in the preview just to see what they'll look like in a list, like we did with the game summary. Yeah. The question is, can I use navigation-like things in here? Well, I am. I'm using Toolbar. That's essentially kind of a navigation thing. But there are other things, like the title of this view can appear in there, and I'll show you that in a second. But yes, you can use them in here. And you know what? If you use them in here and it's not in a navigation stack, it just won't appear. It's not going to break anything. It just won't appear. Back to our game chooser right here. It's really powerful. It's working great. When we go here and make guesses, we know that it's updating our attempts over here. This is awesome. I can switch between games. I can go play this game for a little while, then I can go back here, then I can go back to this game, and it's still in progress. This is great. But I'm going to show you a way that we can do this whole thing that's different, which, because our app is simple, is not necessarily a better way. It's probably equally good. But that is, we're going to have our model be a class. It's going to be a reference type. We're going to pass it around by reference instead of passing it around by binding. And I'm mostly doing this so you see what it looks like to have a model that is a class. I'm not necessarily doing this because I think it's wrong that we're passing our whole game by binding here. It's not too bad. It's getting close to being a sophisticated enough model that might make sense to be passing around a reference. But mostly I'm doing this because I want you to see what it looks like to have your model be a class, be passed around by reference. So how do we do that? Well, it's very simple. Here I'm going to go to my model. This is my CodeBreaker. And instead of it being a struct, it's going to be a class. Now, this is going to have some ramifications, obviously. And we can see some of them with errors that happen right off the bat. For example, mutating makes no sense in a class. That's because every func in a class is mutating. You have a pointer to the thing in the heap. You can do anything you want that thing in the heap. Again, that's the wonderful benefit and the horrible, possible damaging thing. It's fully mutable. Classes are fully mutable. So we do not put mutating funcs. Swift does not need to know which ones are mutating because they're all mutating. So I'm just going to take this mutating func out of here for the three things that we have so that this will compile. Now that this is a class, we're not going to pass it by @binding anymore. So let's go back to our game chooser here. Actually, let's go to our CodeBreaker view, start there. And this @binding right here, I'm just going to change that, believe it or not, to let. Now, let might sound like, wait a second, you can't do let because I'm going to be modifying this thing. But let just means the pointer is a let. It doesn't mean the thing it points to is a let. So I'm still going to be able to change that CodeBreaker game all I want, even though I have a let pointer to it. Notice also I'm leaving it as data shared with me, because when you pass something by reference, that thing is being shared with you in a big way. So let's go back to our game chooser where we used to be passing the binding here. We no longer need to pass a binding. We can just pass a reference to our game. And of course, we don't need these $sign things here either. Sorry about that. This is hard to grab. We don't need these $sign things here because we're no longer passing it by binding, so we don't need that magic. And one sad victim of this is that edit actions does not work. Now, I'm going to show you in a moment here how to still do those when you have a class. It's a bit more work, but unfortunately, edit actions does not work as is. And there's one more thing, of course, we broke, which is our preview. Right? We've got this CodeBreaker preview down here, and it's passing a binding, and it's just going to not pass the binding. And yes, it's perfectly fine to have an @state, which is a class. @state works for classes too, but the @state is holding the pointer, not the thing it points to. The thing it points to is always kept in the heap. Let's go back and see if this all works. We got this. Here's Mastermind. We can go here. Let's go ahead and make a get. Oh no. Oh, we broke everything. What's going on here? Anyone want to guess why this is not working? Yeah, exactly, yeah. Exactly. So you guys were paying attention in the lecture. That's great. It needs @observable. And I intentionally didn't put that on here because I wanted you to see what happens if you don't do it, which is that I'm going green, 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 green here, and that is being set to green, green, green in my model. It's just that the UI is not updating. UI can't see it because that's being changed in the heap, and Swift has no idea that things are happening in the heap. So that's why we need to go back here, and anytime we have a model that's a class, we say @observable. That is actually going to remake all of our vars into underbar vars where the storage is, and then computed vars that are accessing the underbar vars, but updating SwiftUI all along the way. So there's a massive amount of code that's being generated that you can't even see by this @observable thing, but it makes it so that instantly over here, I guess I could get this to stay by doing this. Now it's working. I'm changing it to green, 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 and the UI is getting updated to show it to me. Can anyone guess why before when I went click, 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 it was still moving the selection thing? Why was that still working? Because that selection thing is not in our model. That's something we do in @state in our view. It's not in the model. So it was updating because @state continues to be updated even if your model was completely not @observable and thus not being observed. Let's go back and do the delete edit actions that we had before. And the way we do this here is with some view modifiers on ForEach. ForEach has two view modifiers, one for doing delete, swipe to delete, and one for doing the move. So that means my list is going to have to go back to being a ForEach kind of thing here, because this is a ForEach thing, not a list thing. Again, very little change here, right? I'm just, the ForEach that list has hidden, I'm just unhiding it and doing it myself. And the reason for that is I want to say on delete, and on delete calls a closure for you, and it gives you the offsets of the things that were deleted. Now, 99.9% of the time, this is one thing, but this is built to delete multiple things at the same time. If we take a look at this offsets, its type is index set. So an index set is a set of indexes. As simple as that, it's just a collection of indexes. Again, this is going to usually have one item in it, the thing you swiped to delete on. And what's really awesome is that array has a nice built-in function that will take this offsets and delete the things. It's game.remove @offsets. You give it the offsets, and it will remove everything at those indices from the array, which is exactly what we want here. And similarly here, sorry, it's not game, this is games from our games. And we have the same thing with onMove. So onMove takes two things. It takes the offsets they're moving and the destination that they're moving to. And it also has a nice little games.move from offsets, the offsets, to offset the destination. This is how you do it if you are using a class and thus can't use the list with the $sign that we had before. So let's make sure this is still working. Swipe. Yes, sure. It's gone. And edit. Well, we probably won't be able to actually do it, but you get the idea. The move is there as well. Right. Any questions about that? Pretty straightforward there. Now, one thing about classes that's really cool in your SwiftUI code is that they have a strong sense of their identity. So when we have a class in an array like this, we almost never do this ID / thing because we're going to make that class be identifiable because it already has such a strong sense of identity. In fact, if I go to my CodeBreaker here and I say that this class is identifiable, and I pray and hope that it can synthesize it, it can. Because, again, classes, we know their identity. It's essentially their pointer to the heap is their identity. And so it just works. So back here in our game chooser, we got for each game's game. It is a nice feature of having your model be a class that you get a lot of good-looking code like this. For each games do the thing there. All right, another thing we do with classes, since we have such good identity and they're identifiable, is we do our navigation links in a little different way. This navigation link, I'm actually giving it the thing I'm going to navigate to and the thing that appears in the list. You see both of those views here, CodeBreaker view and the game summary? Well, unfortunately, that means it's making that destination view for all my list items. That could be inefficient. What if I had 10,000 list items here? Yikes. Make 10,000 game CodeBreaker views? Inefficient. So there's another way to do navigation links that looks like this. And I'll do them side by side for a second here, which is navigation link, where you say a value. And then all you provide here is the label. So you don't do both the label and the CodeBreaker view here. You just do the label. And instead, you're specifying what thing you want to show. And then in a different view modifier farther down here, we're going to specify which view to show that kind of thing. So the value that we want to show with this navigation link is this game, but we're going to specify the view, the CodeBreaker view, to display it somewhere else, and that's going to happen down here. Outside of the list, I'm going to say navigation destination for CodeBreakers, and I say CodeBreaker.self. CodeBreaker.self means the type CodeBreaker. So when I say navigation destination for CodeBreaker.self, I mean navigation destination for values that are of type CodeBreaker. And then it's going to pass the value that was given to me. And here's where I'm going to say, okay, make a CodeBreaker view and pass that game along to it. So you see how I've specified the view to use to show a certain value somewhere else down below. So it doesn't actually execute this code until I tap on it. Now, this is not working. It says right here that this requires that CodeBreaker conform to Hashable. And you can kind of imagine why this is, because the ForEach here, and the list in general, wants to be keeping a hash table of the values, which is the CodeBreaker games, the Mastermind game and the real-time game, to the view that got built by the navigation destination down there that's showing it. So, of course, it needs to be hashable. Same reason anything in ForEach needs to be hashable. And these are the values that are being shown, but it's still, we're looking them up in a table because we're associating them with a view. So we have to make our CodeBreaker be hashable. It's identifiable, but it's not hashable. We didn't make it hashable. So let's go do that. And I told you we were going to have to do this, and now we really are going to have to do it. We really are going to have to implement the hashable protocol here for observable. So I'm going to say, comma, hashable. And I'm going to cross my fingers and hope that it can do it. Oh, it can't. Oh, no. And this is really too bad. And I actually think it should be able to do this, but it can't. And so what's it saying here? It says, oh, CodeBreaker does not conform to equatable. Well, that's because to be hashable, you got to be equatable. So Swift is saying first things first here, bud. You got to be equatable before you can even be hashable. So, all right, let's go ahead and make it equatable. Here we go. Ready? Static func. It's called equals equals. It's got a left-hand side that's going to be a CodeBreaker and a right-hand side that's going to be a CodeBreaker. And it returns a bool as to whether the left-hand side and the right-hand side are equal. So how am I going to implement this? Well, I'm going to say that unless two CodeBreakers are exactly the same CodeBreaker, in other words, the same thing in the heap, then they're not equal. So how can I check to see if their pointers are the same, essentially? Because I don't see any pointers, and we don't use pointers in Swift. The fact that classes are by reference, the pointer that's actually being used, not visible to us. But I do know that this thing is identifiable, and it has an ID, right? That this identifiable right here, synthesized a var ID for me, and we know that that ID at the worst is a proxy for its pointer, if not the pointer itself. We don't know what it is, but it definitely represents the pointer. So I'm just going to say if the IDs are the same, then it's equal, right? So I'm just going to return the left-hand side's ID equals the right-hand side's ID. And this ID, again, is the thing that got synthesized for us because we said we were identifiable. So this is very strict equality. Truly, this CodeBreaker has to be exactly the same one in the heap because I'm basically checking their pointers here. I'm using their identity, their true identity. And now what about hashable? What's that? That's func hash into, here it is, and I'm supposed to do this hasher combine, and look what the AI is recommending that I do. It's saying, oh, just hash your ID, dude. That is really going to be a clear hash code for you that is going to work, and it is absolutely right. And that ID has to be hashable because I can only combine hashable things in my hasher. But is that ID hashable? Yes, it is, because identifiable requires that the var ID be hashable. You can't have a var ID without it being hashable. Remember the identifiable protocol, it had in there associated type ID : hashable. So we know it is hashable. Now, another thing that's interesting about this is that probably I wouldn't put these things here at the top of my class. They're just not that important. And in fact, I might not put them in my class at all. I might put them in an extension. It's very common to put conformance to a protocol like this in an extension. So I'm going to do that. I'm going to cut this out of here. I'm going to take these things off of here. And I'm going to go down to the bottom of this file and say extension to CodeBreaker that implements identifiable and hashable, and of course equatable because of the hashable, is this thing right here. So I'm putting this conformance into an extension, just like I did in the slides with arrays conformance to equatable where the things inside are equatable. Remember, I did that in an extension. I'm doing this in an extension as well. So that keeps my class kind of clean up here. Let's make sure this didn't break anything. I'm going to go back to my game chooser here. Ready? Click. Yeah, looking good. Is it this game? Yes. I'm going to guess and go back. I have one attempt. Go back. It's still there. Go to a different game down here. This thing. We'll guess here. We'll go back. It's still good here. Everything is working. So I'm passing my CodeBreaker games that are stored in this array by reference. This array essentially has pointers to CodeBreaker games. And then I'm passing it via pointer with this CodeBreaker View game. The last thing I want to show here is that the navigation link way of doing things this way with the value, you can actually have multiple navigation links with different values. You don't have to always have the same ones, and I'm going to do that here. I'm actually going to put a cheat code in for every one of my games. I'm going to have a navigation link where the value is my game's master codes, pegs. And then I'm going to have the thing here just say text cheat. So look at what happened to my UI. I still have my game summaries, but now I have the little word cheat. And when I click on this cheat, I want it to navigate to showing me the master code. So I made the value of the link be the master code's pegs. And now all I need to do is have a navigation destination that when you're showing array of pegs, show me this thing with some view. So let's do that. Dot navigation destination for what? Array of pegs, because that's what this is. The game of master code is an array of pegs. And when I'm given that, I'm going to have my pegs in. That out of the way. And here I need to show the pegs. So I'll use peg chooser again. Peg choices is these pegs. This is choices. What is this? Oh, sorry, this is dot self. So I have to say for array of pegs dot self. That means for things that are of the type array of pegs. And here we go. Here's Mastermind. Cheat. Ooh, green, red, green, blue. Oh, let's go over here and try green, red, green, blue. I think that's a good guess. I got it. So here I put these in here, these two navigation links, because I just want you to understand that we can have multiple different things in my list that have different values, and I can show a different view for each of them, depending on what kind of thing they are. And that's what I'm doing, these two things. Okay, we're going to stop there because time's up. And what I'm going to do on Monday is we're going to make all of this work on iPad and on the Mac. Okay? And then hopefully, if we have enough time on Monday, which I think we will, we'll start by creating a mechanism for creating a new game. Because all we can do now is look at these 3 games that we have here. We want to be able to create new games, and we want to be able to edit games, to add new pegs to them. All right? We're going to do all of that. Hopefully on Monday, might spill in to next Wednesday. And then after that, just to give you a far outlook, we will worry about making these things persistent. Because what happens right now, if I restart this game and click Restart, well, it goes back to 0 attempts. All these games are reset to 0. And that's really going to be annoying for you guys in A4 because you're going to be doing this essentially for your games, and when you restart your game, you lost all your games. But not to worry, in A5, we'll make them hang around. Okay, so you're just going to have to deal with that annoyance for one assignment. All right, that is it.